Hi, my name is Anthony, and today I'm going to be talking about arithmetic and geometric sequences. Let's first start with arithmetic. Now, an arithmetic sequence is a sequence of numbers with a common difference or the letter D. If the difference are all the same, then it is an arithmetic sequence. And if we plot the points, it should be a linear curve. In the example sequence, we have 2, 5, 8, and 11. In order to find the difference, you subtract the nth plus 1 term and the nth term. In this case, we can use 5 minus 2, and the difference would be 3. The main formula for arithmetic is an equals a1 plus n minus 1 times d. With this, you can find the nth term of a sequence and with the given first term and difference, or you can also find the first term with a given term and difference. Let's try practice A. We are given negative 2, 2, 6, 10, and 14. Now if I subtract 2 minus negative 2, I would get 4. That's our common difference. So our general term would be a of n equals negative 2 plus n minus 1 times 4, but we can simplify it to a of n equals 4n minus 6. Then it asks us to find the 59th term of the sequence. Since we already have our general term, we can plug in 59 for n, and then the equation would be a of 59 equals 4 times 59 minus 6. We use simple algebra to find a of 59 is 230. Now, if we have a sequence that is changing signs, instead we ignore the sign and find the common difference. And if the sequence starts with a negative term, then you place negative 1 raised to n in front of the general term. And if it's a positive term that starts first, it's negative 1 raised to n plus 1. Let's try practice D. It starts with 3, negative 6, 9, negative 12, and 15. Now remember, you have to ignore the signs first, just kind of as if you're ignoring like your mom's calls or an old ex, which is pretty simple. You find the common difference, so 6 minus 3 equals 3. Now the general term would be a of n equals 3 plus n minus 1 times 3, or a of n equals 3n. But now since the signs change, you put negative 1 raised to n plus 1 in front of the sequence. So now the formula is a of n equals negative 1 raised to n plus 1 times 3n. Another notation that you'd be seeing would be the n factorial, which is 1 times 2 times 3 times 4, and it keeps going until you reach times the nth term. For example, 2 factorial would equal to 2 because 1 times 2. 3 factorial, which is 1 times 2 times 3, would equal 6. And 4 factorial is 1 times 2 times 3 times 4 would equal 24, and so on. Now we're going to move on into geometric sequences. Now with geometric sequences, instead of addition, you now have to do with multiplication. Instead of finding the common difference, we now have to find the common ratio, or r. The points, if plotted, should make an exponential curve. So in the first sequence we see, which is 2, 4, 8, and 16, in order to find the common ratio, you have to divide the nth plus 1 term by the nth term. So 4 divided by 2, which would equal 2, that would be our common ratio. The general term for a geometric sequence is a of n equals a1 times r raised to n minus 1. Now let's try example B. We have 1, 4, 16, 64, and 256. So our common ratio would be 4 divided by 1, which equals to 4. Now our general term is a of n equals 1 times 4 raised to n minus 1. And the question also asks for the 17th term, so we plug in 17 for n. A of 17 equals 4 raised to 17 minus 1, and that would equal 4,294,967,296, or which is what I wish I had in my bank account. Practice problem C is a little bit different. Instead of going up, it's now going down, which is exactly how my bank account is looking right now. We have 16, 8, 4, 2, and 1, and so on. So the ratio is 8 divided by 6, which equals 1/2. Our general term will be a of n equals 16 times 1/2 raised to n minus 1. We plug in 17 for n, and we get a of 17 equals 16 times 1/2 raised to 17 minus 1, and that equals 1 over 4,096. Let's check out number 2. John found a part-time job which starts at $9.20 per hour, and his wage goes up 23 cents for every 50 hours he works. After 50 hours, his wage goes up to $9.43, and then $9.66, and so on. Part A is asking for how many hours should he work so that his wage is over $12. So we know A1 is equal to $9.20, and the difference is D is equal to 0.23. To find the number of hours, we need to find n and multiply it by 50. We set up our formula with what we know, which is 12 equals 9.2 plus n minus 1 times 0.23. You distribute the 0.23 and subtract 0.23 from 920, and we have 12 equals 8.97 plus 0.23 n. Subtract 8.97 from both sides, and it should equal 3.03, and then you divide 3.03 by 0.23, and n should equal 13.17. But since we have to have it more than $12, we round up to 14. Now you multiply 14 by 50, and you should get 700 hours. And that's most of the geometric and arithmetic series.